Hello and welcome to T3 Day 13 of Honors Precalculus. Today we're going to talk about permutations and combinations. So first, let's talk about permutation. A permutation is a set of ordered objects. So the order matters. It matters. It's super important. A telephone number is a permutation. You can't just mix up the numbers and have the same telephone number. The order matters. So, for example, how many different ways can we put Billy, Ralph, and Mackenzie in order? Well, the first person, let's say, could be Billy, the second person could be Ralph, and the third person could be Mackenzie. We'll do M-A-K. Now, after Billy, it could go in a couple directions. After Billy, you could get Ralph, or you could get Mac. But then if you had Ralph, the only person left here would be Mac, and the only person here would be Ralph. And you can finish the other one similarly. And you end up with these options. So each full path represents an option. So there's 1, 2, 3, 4, 5, 6 of them. You notice you could have started with 3, and then each broke into 2, but then there was only 1 left. So you can think of it as 3 times 2 times 1. Here's another example. How many 3-digit numbers can you have if you only use the numbers 0 through 5? We can repeat numbers. So how many are there? There are 6 numbers here. This is the key. You could repeat. So there could be 6 in the first slot, and then 6 in the second slot, and then 6 in the third. So it's 6 times 6 times 6 times 6. 6 to the third is 216. The key here is you could repeat. The last one we couldn't. You couldn't repeat the entries. So how many 3-digit numbers can you have if you only use the numbers 0, 1, 2, 3, 4, 5 and do not repeat? Well, the first one, again, could be 6, but whatever number you use, you can't use it again. So then you're going to end up with 5 choices and then 4 choices. So that turns out to be 120. So if you don't repeat, you end up with less. How do you write this out here? We're going to write this with factorial notation. This represents factorial, the exclamation point. Nice and surprising. The definition, n factorial, is n times n minus 1 times n minus 2 all the way down to 1. So for example, 7 factorial example is 7 times 6 times 5 times 4 times 3 times 2 times 1. You're going to memorize a lot of these. So how do we write 120 how do we write this right here as factorial notation or in factorial notation? Well, it's going to be 6 factorial on top. That's 6 times 5 times 4 times 3 times 2 times 1. But we don't have anything past 4. So what we're going to do is we're going to divide it by 3 times 2 times 1. Because if you did that, you would cancel these out right here. What does that mean? It's 6 factorial over 3 factorial, which is 120. This would be the factorial notation for 120. So what about this one right here? How many different ways can we put the letters A, B, C, D in order with no repeats? Well, there's 4 for the first slot, 3 for the second slot, 2, and then 1. So that's 4 factorial, which is 24. You'll memorize a lot of these factorials. Next question here is, suppose we have 8 athletes competing for gold, silver, and bronze. How many possible ways can the medals be awarded? How can we write this in terms of factorials? Well, we can think of it as gold, silver, and bronze right here. So how many could come in first, second, third? Well, there's 8 if you just pick that could have gold, but once someone gets gold, they can't get silver. So we're going to multiply that times the 7 that are left and then times the 6. And this is going to be 8 factorial over 5 factorial. We've cut off everything less than 6 here, which turns out to be 336. You can think of it as how many, if there's 8 athletes, how many ways could the top 3 spots be awarded? So what we've been doing is this. If we have n items, the last one we had was 8, but if we had n items and we want to pick k of them, so in the last example that was 8 and we were picking 3. That was just in the last example, but we're generalizing now. And we're doing it in order without repetition. This is key. Without repetition, we get n factorial over n minus k factorial. In the last example, n was 8 and k was 3. So in that last example, it was 8 factorial over 8 minus 3 factorial, which is 8 factorial over 5 factorial. That matches what we had above, from above, right up there. We use this notation here. This is really important here. This notation is notarized P, N, comma, K. So this one right here would have been P, N, which was 8, and K was 3. or we write it like this. This is the really common one, NPK. So it would have been 8P3. Mathematicians just really like to write things in as few keystrokes as possible. Now, you can use your calculator to calculate these things. Where you're going to go is, on your calculator, there's the math button, and there's multiple ways to get here, but this is what I like to do. You go to math, and then you go over to probability, it's PRB, and then you're going to see NPR, and you press enter, NPR. So what you have to do, and we'll help you with this in class, if we want 5, 2, what it's going to look like is 5 NPR2 on your calculator. So you type 5, math, go over to PRB, go to NPR and 2 and press enter, and you're going to get 20 on this. This one right here, again, it's going to be 10 NPR and then 4 on your calculator. So I type 10, I then do math, go over to PRB and go to NPR and then hit 4, so 10, 4, it looks like that. We end up with 5,040. What this is 10 factorial over 10 minus 4 factorial. That's what that equals right there. And then this over here is 5 factorial over 5 minus 2 factorial, which is right there. So you need to use this. Now be careful, this is NPR. There's another one, NCR. So go to NPR. So that's a combination. A combination is a set of an unordered pair. So the order doesn't matter, unordered. Fruit salad is a combination of fruits. The order of the fruit that we add doesn't matter in the final product. So suppose we have 10 athletes and we want to pick 4 for a team. Doesn't matter what order we pick them in. So you could pick 10 as your first one, you could pick 9 as your second one, 8, and then 7. And that's if ordered mattered, but it doesn't. It doesn't matter. That's how many teams of 4 we can pick if order matters. But each of those teams of 4 can be mixed up how many ways? They could be each mixed up 4 factorial ways. So what that means is if I pick a team of like A, B, C, and D, how many different ways can we mix those up? We can mix those up 4 factorial ways. The way you would write this in total factorial form is 10 factorial over 6 factorial. That's this part right here, written like we did above. And then what you're doing is you're dividing by 4 factorial, which is the number of ways each pick of 4 can be picked or ordered. So this would be the number of combinations. So what does this simplify to? 10 factorial over 6 factorial, 4 factorial. When you do this out on your calculator, you end up with 210. Now combinations are going to be much smaller than permutations because for every, 4 factorial is 24. So in this case, if order mattered, this would be 24 times larger. But the key thing to remember here is in permutations order matters, but in combinations they don't. So how many different ways can you give 3 marbles to 8 people? Well, what that's going to be is it's going to be 8 factorial over 8 minus 3 factorial, and that would be the permutation, meaning if order matters, but it doesn't, so you divide by 3 factorial, and this simplifies to 8 factorial over 5 factorial, 3 factorial, and that's 56. And if you're looking for where the probability button is, the exclamation point, that's under math probability 4. You'll see the exclamation point there. So the general form for combinations is this. What you're doing is you're doing the permutations, and then you're just dividing by k factorial. So all we have here is the permutations divided by k factorial, and what that comes out to be is this right there. And what this notation means, nck here, nck, it equals this, n factorial over k factorial, n minus k factorial. That's what we were doing above. This is just generalized. So on your calculator, if you want to evaluate these, what you're looking to type is 5NCR2. Keep in mind this is now a C right here. So I'm going to type 5 and then hit math, go over to PRB, hit enter at 3, and CR, and then hit 2. Combinations here is 10. Ooh, this is going to be 10. What that was 5 factorial over, 2 factorial, and then 5 minus 2 factorial, and that's what that equals right there, because this is the NCR. There we go. So I want just to clean one thing up. I was calling this R. It should be just called K. It's called K the entire time. My mistake, it's always called K. And it's called K on there, but it's called R on your calculator. So down here, when we were doing this right here on your calculator, you're going to see R, but we call it K. K and R are the same here. So for this one, it's going to be 8NCR5. And remember, we call it K in the sheet, but it's called K on your calculator. So what do we end up with here? When you do this on your calculator, you do 8 and then math PRB NCR. You end up with then 5. So on my calculator, this is literally what I have. And then I just hit enter. And when I hit enter on this, I end up with 56. And this is just 8 factorial over 5 factorial, 8 minus 5 factorial. And that equals 56. So again, in this sheet, K and R, K is what we call the second number, but on your calculator, it's called R. So really, the biggest thing to walk away with is combinations are unordered. The order doesn't matter, but for permutations, order does matter.